My name is Camilla Berretta, and I'll be speaking about my experience navigating my cloud engineering internship at CrowdStrike, which is where I am still an intern right now. And this is what I used to do in my previous life. I come from the classical music industry, like Guinevere, playing in symphonies. I play viola and violin. So while this is my first talk, it's not the first time that I'm standing in front of an audience. So thank you for coming. So during the pandemic, I started coding, and then I started a full stack boot camp, the ADA Developers Academy. And I graduated about a month ago. This is the stack that we did in boot camp. The transition from full stack to a cloud internship is quite daunting. And this is what I did in my internship. And I'm still a newbie myself, but what follows are a series of tips, some more concrete and some more abstract. And these are strategies that truly help me navigate this transition. One of my first and most important challenges as a first-time cloud engineer was grasping the CI/CD pipeline. I've reflected on what made this challenging for me, and maybe my reflections might help new developers like myself or those preparing to onboard new developers. The thing is, usually you can learn a topic by breaking it into a series of smaller parts, and then mastering each one individually, and then putting them all together. You divide and conquer. And this is how I would generally practice a piece of music, and pretend this is 8 pages long. So you break it up into 1 page at a time, and then you break it up even further in one section, for example, 3 lines. And what this meant is that my neighbors would hear me practice this piece of music for 3 hours at a time until I conquered it. And then I would go on to the next, and then add them all together. But when trying to grasp the CI/CD pipeline as a beginner, divide and conquer isn't a sufficient strategy. Because so many different names and tools that all relate to the CI/CD pipeline get thrown at you, and it's hard to know which ones are useful and how they relate to the whole. So looking at definition of each tool didn't help me. Asking somebody to explain it to me wasn't that helpful. For example, take unit testing. I'd done it in boot camp. I'd worked with frameworks like Mocha, Jest, and PyTest. But why was it called unit testing, and why now did we have all these other kinds of tests? Chaos testing, integration tests, stack test. So I could learn how to run each. That was fine, but something was persistently missing from my understanding. So to draw an analogy, consider the arch. This is my hometown, Perugia, Italy. And this is the Etruscan arch, and one of the reasons why tourists come to my hometown. I used to live pretty close to there. And it's one of the 7 doors or arches to Perugia. So the arch, the whole, is composed of its parts, the stones, without which the arch would fall down. But without seeing the whole arch, the role played by each individual stone made no sense. Why is it shaped like that? Where does it fit in? And likewise, without seeing the whole CI/CD pipeline, I couldn't get the point of any of its parts. So it wasn't until I took the time to study an ideal version of the CI/CD pipeline in its whole, with its fundamental stages of development, build, test, environment, pre-production, and production, that it all started to make sense to me. And initially, I didn't even know what production or pre-production was. Then for each tool, I could finally place it in the pipeline. I could ask the following context questions. When? Which stage is it in? Which fundamental stage is it in? How does the tool get used? And then why does the tool's unique function support the overall pipeline? So I started with the thing that made sense to me the most, so then I could relate it to the whole. When? Where is it in the stage? It's in the development stage. And how? I can learn how to run it. And then why? To get rapid feedback early in the developer loop. So I grabbed onto all that reference in my head and placed it and visualized it in the pipeline. So I could do this then with all the other terminology and tools that I was thrown at, and put them in the context of the pipeline. And it's also important to remember that this is an ideal pipeline, and necessarily you won't have the same at your organization. So for tip number 1, to understand the stones, first learn of the arch. So here's the thing about a first engineering job in general. You're going to want to dive in and start proving yourself right away. During onboarding, you're going to have to set up all these new tools without much of an idea of what they are and how they will be used. After onboarding, you're going to be given your first ticket and you're going to want to prove yourself right away. At least I was. I wanted to get coding, and even if I didn't really understand my tools. So let's say you're building a piece of IKEA furniture. You'll probably be tempted to whip out all the tools and start building the thing right away. And with exact IKEA directions, this may work out fine. But what if you want to go on to building more furniture or have a long career as a furniture maker? You may want to sort your 5mm wrenches into a cabinet and learn how to use them in detail. So I'd say don't succumb to the pressure to produce right away. Instead, invest the time to build a cabinet for your tools, get good at using them, and it will save time in the long run. So let's start with the hammer and wrench of the software developer, your IDE, your terminal, and your text editor. If you type a key combo all day, every day, how much will you gain in the long run by memorizing it? So I followed some very practical advice from Alyssa Hirsch, who's a senior engineer at Amazon and a fellow alum from my bootcamp, Ada. So I taped a Post-it on my monitor with 5 Golang commands to memorize. And then once I had them memorized, I would just throw that away and just do it again. And do the same with my command line and my text editor. Because I know that for music, that a small amount of annoying repetitive drills will make things smooth in the end and will just really pay off. So here we have a violinist, repeating, drilling, and then I have myself repeating a command that was awkward to memorize. And in a moment, I'll give you an example. Yes? Sure. Is this good? Oh, yeah. So in a moment, I'll give you an example of a tool that really paid off to get to know telepresence. But further, it pays to inventory your tools with a spreadsheet like this. So you have a name of each tool, then the 5-minute elevator pitch, and then what's it used here at your company, and then any kind of documentation and links. Paying so much attention to the tools might feel counter to the advice in tip 1, but in software engineering, like in music, you need both principles. You need to understand the context of the whole so that you understand how the parts fit in, and then understand and master each tool so you can accelerate your progress with the whole. This takes me to tip 3. I had a mentor, Scott, who introduced me to the idea of the developer loop at the beginning of my internship. I found that the best question to ask is, what would you do if you were starting again as a software developer? And so Scott told me that the #1 recommendation that he would give himself again was to accelerate the developer loop early on. So what is the developer loop? It's a process of writing code, running it, observing the results, and adjusting your code based on that result. So that feedback cycle should become almost part of your muscle memory. Scott's advice was to make it as fast as possible. In fact, one of the things I appreciated about coding early on was this feedback that I would receive instantaneously, unlike in music where you have to, and this is supposed to be a loop running through, so you know what's going on. Instead of music, the performer and the listener have to be the same person, so it's much harder to get rapid feedback. So right away, I saw the problem with how I'd been learning so far. Depending on the project, sometimes I didn't even know how to run unit tests. Everything was still kind of unfamiliar. And so I realized that I had to clarify how to run effective testing, and then I needed to work on making my developer loop as fast as possible. Because I could see how the lack of a process was slowing me down, and I was not reaching the optimal flow state. A common way to describe the developer loop is that there are 2 parts to it, the inner loop and then the outer dev loop. The inner dev loop is what I've just been talking about, where individual developers write and test their code. While in the outer dev loop, this comes into play once the code is pushed to version control. And the outer dev loop includes automated CI/CD pipelines, like I talked about in tip 1, And then progressive delivery strategies, like feature flags, A/B testing. So what does it mean to tighten the developer loop? It's reducing the cycle time of the system by streamlining the write, build, run, and write again process. And so as a programmer, what does this mean? You work on what you can control, the inner dev loop. And so how do you do that? You have to go through the change, code, test, run, evaluate at least once to define it and recognize it. And then, so you remember everything, you write the steps down. And I'll talk more about this in tip 7. And another thing to consider is that when you're working with cloud native technologies, things get more complex. First, developers need to be more involved in the outer dev loop, even if they spend most of their time in the inner dev loop. And now developers have to take extra steps in the inner dev loop to build and test containers, handle dependencies, and other things. And this can add a lot of time. So Scott's advice was sound: find ways to optimize the feedback loop. The goal is to get yourself in a state of flow. So we've talked about speeding up your developer loop, building a toolbox, and then getting to know your tools. Let's get specific about a really cool tool that I found that exemplified these points for me: telepresence. Telepresence is an open source cloud native computing foundation project created by Ambassador Labs, and it's in the sandbox phase. There are various stages for a project. This is for projects that are in their early maturity phase. So what is telepresence? It's a service that can be used to connect your local development environment seamlessly to a Kubernetes cluster via a two-way network connection. This connection is between your machine and your cluster. So you can set it up to mirror the remote pre-production environment via this tunnel. So during one of my first weeks at internship, my mentor asked a smart senior engineer on my team to give me an overview of telepresence. So I took notes as best I could, and he explained things very well. And at least I learned about the tools that I needed to download to run it and how to run it. But the point of telepresence still remained stubbornly abstract. I still didn't get it because I had no idea that the developer loop was a thing and that microservice deployment could eat up lots of time. In other words, going back to tip 1, telepresence wasn't yet useful because I couldn't see the whole. So a couple weeks went by and I still didn't know how to use telepresence other than it would be a tool that I would use some other time in the future. But once I realized that besides running local testing, another much better way to test was to use telepresence, I finally started digging in. This was for my second project. So I revisited the notes I'd taken, reviewed the internal documentation, and tried it out in practice. Telepresence used to be called Service Preview. The name wasn't as catchy as telepresence, but this is one of the things it would do. It would allow me to preview my microservice before I was ready to share my code. So how does it work? This is a very simplified telepresence diagram that I redrew from the documentation. It's a binary application that you download. You can go to telepresence.io. And once you install the tool, it also installs a lightweight daemon on your machine that it spins up once you run it. And so let's assume that your app is already connected to a Kubernetes cluster. In the cluster, telepresence also installs a traffic controller or manager. Then, with the command telepresence connect, the daemon in your local machine connects to the traffic manager or controller via this tunnel, which is a proxy network tunnel. And with this tunnel, your service will be connected to the remote pods and to your application in the cluster. And in a minute, I'll be showing a recorded demo of how you can create that connection, how it works in practice. And by the way, the logo is a blackbird, not a penguin. Kind of looks like a penguin, but it's a blackbird. So with my project, this became very concrete. Since I was creating API routes, I would run telepresence, and then once I was connected to the remote cluster, I could see my changes created in my local branch without having pushed it to main. And I could test my routes without having done this. It was so cool because I could see it before it was ready, even ready to push to pre-production. So I finally understood what telepresence was for. It was for debugging and development. But unlike other kinds of testing, it allows you to preview what you will see in the pre-prod production stages without having to go through the whole cycle of build, push, deploy. So it makes the remote local and the developer loop much faster. So here's the demo. Okay, it's not starting. I'm going to explain it because it goes kind of quickly. So I have a project here. And then I'm going to start telepresence, check that my pods are live. And then with the, I'm going to do telepresence command, connect, which connects my daemon to the cluster. And then once I do that, I will list all the services that are available. Let's say there's 4 microservices. And then after that, I will intercept one of the services so I can preview it. And after that, I will get the preview URL that telepresence offers, and then I'll go into another display, and you'll see the browser on the left is showing what's already in production, and then the one on the right, I'll copy that preview URL so I can see my change, and I'll make my change. Okay, let's see. So this is the application. The one on the right is the one that I will be changing. So here I'm typing telepresence connect. So it's spinning up the daemon. And then it connected it to the daemon in the traffic controller. So I'm checking to see my pods. And then I see that there's 4 services ready to be intercepted. Then I intercepted really quickly. The command is telepresent, intercept, service, and then the port. And then I list it again to check that it was intercepted. In fact, the 4th one is intercepted. And then here I'm going to make my change. The change is incredibly simple, but imagine that this is, much more complex change. I'm just changing the title and then changing an emoji. And then I go back here, copy the preview URL, and then go to my other screen and paste it to the right. And then that's my service changed. So let's talk about a bit more about the two-way street, the secure tunnel. So in the first way, as a developer, you can read out the data to the remote connection. But there's another way through which we can route traffic from the remote cluster into our local machine. So let's assume that your service is connected to 100 other microservices, and those depend on your service, or you depend on them. You could spin them up locally, but then that gets very hard to do at scale. Or you could try to mock them, but sometimes you want to see the traffic live. So this is why telepresence is really cool. You can route the traffic from another service into your machine without having to build, push, deploy. And you definitely don't want to do that in production, although you could. So what are the benefits of telepresence? Before telepresence in development with your service connected to a Kubernetes cluster, it would be quite hard to get fast feedback. So you would build, push, deploy, and then see the code changes. And then you can do some testing, make sure it works, and then do it all over again. Or you could mock depending services locally. Instead, with telepresence, you can just start up the service locally, type telepresence connect, and then your service is connected, and you can see code changes instantly. And additionally, you can test with other microservices that depend on it. And then another benefit is that it's very lightweight. So what are some alternatives to telepresence? Here's some tools that popped up that are kind of in the same space and are trying to solve the same issue. Octeto, and actually the CEO, Ramiro Berretta, is giving a talk in 1 hour. And then Gefira, which is open source, and it's heavily inspired by telepresence v2. And yeah, one thing I haven't mentioned is that telepresence had a v1 and then a v2, and what I just showed is v2, and they kind of changed the architecture of it. And I haven't used these tools. For now, I want to explore more how telepresence works. and I really like how it enables me to mirror the remote environment without having to go through the long developer loop. And it's really satisfying to see the changes on the fly. Okay, so let's go on to tip 5. One of the first and most common pieces of advice I heard when preparing to go into my internship was that I shouldn't be afraid of asking for help. So the advice is to ask questions and that you shouldn't stay blocked for too long. You should ask for help sooner rather than later, which is something that doesn't come very naturally to me, and I truly had to push myself to do. For example, I went through my entire boot camp without asking a single question in the study hall channel, and then I went to office hours about twice before my final project. I wouldn't recommend it, but honestly, that was okay during boot camp. It made me pretty independent, but I knew I had to switch gears in internship, and so I made myself ask for help more often than is natural to me. So people say to ask all the questions and don't wait too long to do that, but it is easier said than done. So what makes this hard in practice hard in practice is that, especially as a first-time engineer, you can appear not independent enough. This is a common lament that I heard from other classmates at other internships at the beginning, that their mentors and managers didn't think that they were self-sufficient enough. The third week in, my friend Chris, and this is not their real name, was reprimanded by their manager for asking about something one too many times, and was not so subtly reminded about that independence was one of the core values of the company. So while that was probably not the best thing a manager could have done at the very beginning of somebody's first internship in tech, you want to avoid creating that impression as much as you can. So it's important to find engineers who love to help, are knowledgeable about practically everything, and won't mind newbie questions. In other words, find your Steve. So who is Steve? Steve Klassen is the inspiration for this tip. They are a cloud engineer at CrowdStrike, and they are not part of my team. Another engineer and alum from my boot camp introduced me to Steve. And they set up a private channel where me and some other ADA interns could ask any questions we might find too intimidating to ask. So right away, they set up an atmosphere where I did not have to shy away from asking newbie questions. And I still ask Steve questions to this day. So how do you find your Steve? Of course, this could be Stefania, and it could be somebody on your team or not just outside. And I was really lucky that I was introduced to Steve right away. But in case I hadn't been introduced to them, there were clues. They were very present in the Slack channels where people asked for onboarding help. And I had already seen their name in documentation that they wrote before I even got introduced to them. So search Slack and find anyone who pops up often willing to help newbies. And a lot of people are very helpful, but you can tell by the language when somebody is super willing and inviting and comes back to check back in. And this kind of person loves to nerd out on the details. And they are also open and non-judgmental. So if you eventually cannot find one Steve, then your Steve might have to be an amalgam of multiple different Steves. The Steve that can help you with your basic command line issues, the person that can help you figure out basics of the language, and then the person who can help you navigate your projects. And a friend of mine who initially told me about Steve and who left the company one day messaged me. And she said, "Hey Camilla, it took me a while, but after 6 months, I finally found my Steve here at company X." So it's possible to find Steves everywhere. So some of the previous tips about understanding the CI/CD pipeline didn't really click for me until I was able to see how a deployment works fully. I was able to watch code from my first project deployed to production. As I'm an intern, I didn't do this myself, but my wonderful tech mentor, Will, suggested I should shadow to see how this occurs. So I did that a few times, and I intend to do this more. So what I recommend is to shadow as many as you can, and then you'll eventually learn the checklist that various engineers go through. And you want to think of how you could eventually accomplish this independently yourself. Another important part of this collaboration when working with a team, communication about deployments is pretty fundamental. And another part is observing logs. Things can get more interesting than you expect after deployment, so you have to make sure that everything goes as planned, and you have to search for warnings and errors. And after you shadow deployment, there's so much that you need to remember. So I recommend taking notes on that. Note-taking is an essential part of learning as a new developer. And another thing you want to document is your blockers. So for my first days at internship, I started documenting my blockers, and it has paid off a great deal. Keeping a record of every blocker you encounter and how you resolved it is a fantastic way to internalize your learning and become self-sufficient. Navigating your internship or first job is like finding your way through a maze. You have to document your progress, or else you'll keep going through the same path over and over. So what do you document? Of course, your blockers, anytime you don't know how to figure out an answer and you have to ask somebody. Or a search that took longer to figure out, so you don't have to repeat yourself over and over. And then anytime you finished working on something and you have a solution that doesn't quite track with what you envisioned initially. And so here are some other not so obvious things to document. Sometimes you have to ask somebody for help. It's inevitable, and sometimes they might even tell you the answer before you're ready to hear it. But ask yourself, how could I have found the solution myself? And then also, for example, if you're learning a new language, like I was in internship with Go, take notes and create a diary of learning the new language and your consistent progress. And why do you document your blockers? Well, it can help you improve very quickly. And also, as I said before, you don't want to be searching or asking the same question over and over. Another reason is to create a trail of how much you've learned and what you've done week to week and day to day, and how much you've been unblocking yourself as well. And then additionally, this will help you write documentation in the future. And then ultimately, your goal could be to become a Steve yourself. It's really satisfying when somebody asks you an answer and then you're able to look back in your notes and then answer those questions and help somebody else for a change. So I hope some of these tips have helped you. I am not an expert by any means, but I definitely feel more comfortable than I did 6 months ago. Thank you for attending my talk. And if you have any questions, Guinevere has the mic.
Yeah, so thank you so much. That was awesome. Thanks for sharing about your journey. I have the mic, and I will come to you if you have questions for our speaker. And yeah, any questions out there? Yeah.
Hi, thank you for the talk. Is there any way you can share the slides?
Sure, yes.
That one's on me. Yes, we will harass all of our speakers and post slides as soon as they are available. Yes.
Definitely. Thank you.
Hi, thanks for the talk. I was wondering about a little more detail on how you took the local code and how it ended up real time in the dev environment.
Sure.
What were the steps there and stuff like that?
So a little more detail on how the local code ended up in the dev environment. Well, so there's a two-way tunnel. And so, I mean, I'm not an expert by any means, but this is through networking. And so you specify the port, and then you intercept the service, the microservice that's already in the cloud, that's already running in production. And so that means that all that data comes and flows through your computer. And so then it's kind of like magic, but it does work. So yeah, I don't know how much more detail.
Oh, so I guess the source code is on the server already, and so that's how it's connected with the microservice, maybe.
I think so.
Somebody has an answer.
I'm guessing that you already built your microservice for your local version of this locally,
Yeah.
and it's just
It's spinning it up.
in the production or the development environment, the integration environment you're working in. It's just directing it past to your server here and then sending it back.
Yeah, I think that's accurate. Thank you. But they have really great documentation on telepresence, and also you can try it out. They give you a free cluster for 3 hours if you don't have a cluster, and then you can check it out.
Oh, that's so cool. I did not know that.
But it's definitely better if you have your own cluster and you already have an application set up. So many questions, that's great.
Yeah, thank you for your talk.
Sure.
It's very interesting. You mentioned a lot that you take notes, you keep track of blockers, all that kind of stuff. What kind of tools do you use to take notes, keep track of blockers, all that
Sure,
information?
yeah. I didn't want to include that because that's kind of based on the person, what you want to do. I actually use a wiki. That's my favorite way of doing it, just because I can link, I can put the code in. You have to find something that is visually appealing for you to reference later, and that you can search easily. So that's my favorite way. I know some other people do it with pull requests to a private repo. That's another interesting way to do it. And of course, there's so many tools like Obsidian, Notion, Evernote that people love to use. Or paper, I mean, or Rocketbook is a hybrid version of that. Hi.
Thank you for the talk. You hit the very last bullet on your slide was looking at becoming a Steve. I found in my experience, that when I took that coach mentality and started helping, it benefited me more positively because I was getting the questions that I never thought that I would ask. And there was a positive feedback loop there, just in my own experience, where I was learning stuff that I didn't need to learn because I wanted to be a better coach to
That's a great tip.
my peers. So, great point.
Thank you. Thank you for being a Steve.
Can you go into the new language diary a little bit? I'm not familiar with that.
Sure, yeah, this is a practice that I started using because I delved into my code right away, into my projects, and I really thought I was like, I still don't understand the syntax because I'd done completely different languages before. It was my first statically typed language. So I started making a little diary. So every day I would start with a little practice in Go. And then I would also create little quizzes for myself, like how do you create a map? How do you create a struct? Things like that. And then I would just retype it every day. And then I would have things that I learned anew, if I did a new tutorial, for example, and write like a few bullet points about that with some code. And then also things that I had to relearn again because I'd already forgotten them. So that kind of helped me like have that chronology of a diary. And it's something I started doing kind of recently, and it's been super helpful. Sure. Oh, completely private.
There's sharing, and then there's oversharing.
Nah, people aren't that interested. It's my own. Or, it's snippets of code that I would do in the playground, the Go playground. It's really fun. Or, yeah, you can just transfer them.
Yeah, for
Otherwise-
anyone who's not familiar with the Go Playground, just go to Google, look for Go Playground, and it's an interactive, like, simulated terminal where you can just run your Go code real quick.
Yeah, thank you.
It doesn't have a lot of syntax help, like, it's not a fancy IDE. But yeah, and you can even copy links and share it to people, and it's a neat tool.
Exactly. Any other questions?
All right. Well, thank you so much for fielding all these questions, too.
Thank you.
It was so great to have you here.
Thank you.